Welcome to my YouTube channel PCM Academy and myself Prosenjit Mollik, MSc in Physics. Today I will discuss about second order linear differential equation. We have already completed the first order portion, that is the first order linear differential equation. Now today I will start the second order linear differential equation. And if you want to get the handwritten notes of these topics, then please go to the description where the Telegram channel link is given. So you can join my Telegram channel and you can get the notes of each and every topic that I have discussed here. Okay. So now let me start with the topic of differential equation, that is the second order linear differential equation. And obviously with constant coefficients, we will discuss first linear second order differential equation but with constant coefficients. Okay. So what is the simplest form of linear differential equation with constant coefficient is nothing but that is d2y dx2 plus p into dy by dx plus qy is equal to r. So this is the simplest form of second order linear differential equation with constant coefficient, because this p and q must be constant. Now how you can solve this equation? So you have to solve this equation by first you have to find out complementary function and then you have to find out the particular integral. So the complete solution of this equation, please note down, the complete solution of this equation is nothing but the complementary function plus the particular integral. Now how you can find out complementary function and how you can find out this particular integral, I will tell you step by step. So first you have to find out the complementary function, and for that case you have to put right hand side as 0. So you have to solve the differential equation which is d2y upon dx2 plus p into dy by dx plus qy equal to 0. When you solve this equation, then you will get the value of y, which will be the complementary function. So in this class I will discuss only about the complementary function, and the next class I will discuss about the particular integral, and then we will add these two, this complementary function and the particular integral, and you will get the complete solution. Okay. And when you will put this right hand side as 0, then this differential equation is also known as homogeneous differential equation. This is also known as homogeneous equation. Okay. So this is also known as homogeneous equation. So let me tell you how you can find out the solution of this equation. So if you write this equation in symbolic form, then what you will get, we will use this d dx as capital D. This is the operator d dx operator. We will write this d dx operator as capital D. So you will, and obviously in that case d2 dx2 is nothing but d square. These two are symbol that we will use. So here this d2y dx2 is nothing but d square y plus here dy by dx is nothing but dy, so it will be your p dy plus qy equal to 0. Now if you take common y, then you will get this d square plus pd plus q into y equal to 0, and this is nothing but the function of d. So what you will have, you will have f of d into y is equal to 0, and this is your symbolic form of this differential equation, where f of d is nothing but simply the d square plus pd plus q, and we can see this is only function of d. Now as y not equal to 0, obviously this f of d is equal to 0. So your f of d will be equal to 0, that means your d square plus pd plus q will also be 0. And this is actually the auxiliary equation of this differential equation. This is the auxiliary equation of this differential equation. Now how you can find out the solution of this differential equation? The solution of y you will get by observing the roots of this equation. So let me tell you the result directly, because the proof is beyond the scope of our discussion, because you don't need to do the proof because our goal is at last problem solving. So let me tell you what are the conditions according to the roots of this equation. According to the roots of this equation, you will get the solution of y of this auxiliary equation. Okay, so let me list one by one that how you can find out y from this by solving this equation, this auxiliary equation, that is nothing but a quadratic equation of D. Okay, so let me tell you. Okay, so let me tell you that if number 1, if the roots are so please 1 second. Okay, so number 1, if the roots are roots of this equation, this quadratic equation, if the roots are equal, first let me talk about distinct. If the roots are real and distinct, okay, say m1 and m2, but m1 not equal to m2. Let me assume that the roots of this quadratic equation are m1 and m2, and these roots are real and distinct, they are not equal. In that case, your solution will be y is equal to c1 e to the power m1x plus c2 e to the power m2x. So please remember this result. We will use this result when we will be solving the differential equation. Okay, so if the roots are roots of this auxiliary equation, what you have to do, you have to first find out the auxiliary equation from the given differential equation, then you have to solve this equation. If you get the roots are real and distinct, that is not equal, then your solution will be c1 e to the power m1x plus c2 e to the power m2x. Here c1 and c2 are constants that we have to find out from the given boundary conditions of the differential equation. Okay, now if the roots are equal, real but equal, so if the roots are real and equal, say m1 is equal to m2 is equal to m, in that case your solution will be y is equal to c1 plus c2x into e to the power m1x. Please keep in mind, in that case you will have c1 plus c2x into e to the power m1x. And the last but not the least, if the roots are complex conjugate to each other, that means if the roots are complex, whenever the roots are complex, obviously they will be in the form of complex conjugate. So if the roots are complex, that is, let me take m1 as alpha plus I beta, so in that case your m2 will be obviously alpha minus I beta. Okay, so in that case what will be your solution? So in that case your solution will be just y equal to e to the power alpha x into a sin beta x plus b cos beta x. So this will be your solution in that case. So you have to remember these three results. One is this, another one is this, and another one is this. So what you have to find out, let me repeat again. You are given a differential equation what you have to do first, you have to find out the auxiliary equation, that is f of d. Then you have to solve this f of d, that is the quadratic equation. Then you will get two roots obviously, and if you find that the roots are real and distinct, then you have to take the solution in this form. You have to write the solution in this form. But if the roots are real and equal, then you have to write the solution in this form. And if the roots are complex conjugate in the form of alpha plus I beta and alpha minus I beta, then you have to solve, you have to write the solution in this form. Okay. So let me give you three examples for this three formula. Let me give you three different examples of second order linear differential equation with constant coefficients of these three types. Okay. So let me give you the first problem. Okay. So our first problem is d2x dt2 plus 5 into dx dt plus 6x, 5 into dx dt plus 6x equal to 0. So this is the differential equation. What we have to solve? We have to solve for x, and there are boundary conditions from which you can find the constant also. We are given that x of 0 is equal to 0. That means at t is equal to 0, x is equal to 0. And another condition is dx upon dt, that is equal to 15, but this is also at t is equal to 0, 15. So what you have to do? You have to first write this differential equation in the symbolic form. Then what will be the symbolic form? The symbolic form will be simply d square plus 5d plus 6 into x equal to 0. And as you can find that x not equal to 0, so your auxiliary equation should be d square plus 5d plus 6 equal to 0. So you will have d plus 2 into d plus 3 equal to 0. That means d is equal to minus 2 and minus 3. So your roots are real and distinct, that is not equal. So what will be the solution? So solution will be y is equal to c1 e to the power m1x, that means minus 2x, plus c2 e to the power, this is not x and this is not y now. Now this is x because we are solving for x. So this will be x, and here instead of x we will have t. So this will be t minus 2t. Okay, minus 3t, minus 3t. So this is x. Now we have two boundary conditions and we have two constants. So you can easily find out the constant also. So if you put that x is equal to 0 at t is equal to 0, then we have c1 plus c2. So c1 is equal to minus c2. This is one. And now if you take the differentiation of this, so what you have? You have dx by dt equal to minus 2c1 e to the power minus 2t minus 3c2 e to the power minus 3t. Now this dx by dt is equal to 15 when t is equal to 0, that means minus 2c1 minus 3c2. Now if you put this c2 is equal to minus c1, then what you will get? 2c1 minus 3 into minus c1, that is minus 2c1 plus 3c1. Okay, so c1 is equal to 15. If c1 is equal to 15, then c2 is equal to minus 15. Now if you write this equation, what will be your x? So your x will be 15 here and minus 15 here. So if you take common 15, then you will have e to the power minus 2t minus e to the power minus 3t. So this is the answer to the problem. Okay, this is the answer to the problem. So this is how you can solve these kinds of problems. First you have to solve for x, then you have to find the constant by using the boundary condition. Okay. Now let me solve another question. okay, based on the next formula, that is when the roots are equal. So, how you can solve in that case? Okay. Now, let me solve next question. Here the question is that d2x dt2 plus 6 dx dt plus 9x equal to 0. So, this is the differential equation and we have to solve it. So, first you have to write in a symbolic form, that is nothing but d square plus 6d plus 9 into x equal to 0. So, what is the symbolic form? So, obviously auxiliary equation will be d square plus 6d plus 9 equal to 0, and you can see easily this is nothing but the d plus 3 whole square. So, d will be minus 3 and minus 3. So, the roots are equal. So, what will be your solution? Solution will be c1 plus c2t. There is c1 plus c2x. So, here will be c1 plus c2t into e to the power m means minus 3. So, this will be your solution now. So, this is how you can solve directly the problems, just by remembering that 3 result I have said earlier. Okay. Now, the last case, that when the roots are complex conjugate to each other. Okay. So, let me solve that also. Okay. So, now let me solve question number 3, and this is a very popular equation I am going to solve. This is known as the equation of SHA, that is d2x dt2 plus omega square x equal to 0. Now, what is the symbolic form of this equation? That is d square x plus omega square x equal to 0. That means d square plus omega square into x equal to 0. That means d square plus omega square equal to 0. So, your d square will be minus omega square. So, d will be plus minus I omega. So, roots is alpha plus minus I beta, but alpha is equal to 0 here and beta is omega. So, your solution will be x will be e to the power 0 t, because it is alpha t, into a sin beta t, that means omega t, plus b cos beta t, that means omega t. And e to the power 0 is 1. So, your solution will be a sin omega t plus b cos omega t. This is your solution. This is how you can solve the problems. And if you are given the boundary condition, then you can find the constant a and p also. Okay. So, I am suggesting you to solve more problems, and more problems are given in the PDF that you can get from my Telegram channel. Okay.